As humanity aims for the stars, going into the great unknown of the universe, we embark on a journey of discovery that will forever change our knowledge of ourselves and our role in the cosmos. With each stride ahead, we reveal secrets of the universe that have been buried for ages and dare to imagine what is beyond. But as we bravely travel where no one has gone before, we must also face the unknown hazards and challenges that come with exploring the final frontier. Today, we'll be continuing with the story of humanity's effort to unravel the mysteries of the universe, to push the boundaries of what is possible, and to reach for the stars. Particularly, we'll be looking at one of our most successful projects, Voyager, and how something might have just made contact in space. NASA's Voyager program is a series of space missions designed to research the solar system's furthest reaches. The Voyager 1 and Voyager 2 spacecraft were launched in 1977 with the primary purpose of researching Jupiter and Saturn. But both spacecraft have now expanded their studies to include Uranus and Neptune as well. Voyager 1 was the first spacecraft to orbit Jupiter and Saturn, returning precise photos and data about the planets and their moons. The spacecraft discovered previously undiscovered phenomena such as Jupiter's Great Red Spot and Saturn's rings. Voyager 1 proceeded to research the outer solar system after completing its initial mission, becoming the first spacecraft to reach interstellar space in 2012. Voyager 2 sailed by Jupiter, Saturn, Uranus, and Neptune, becoming the first spacecraft to visit these ice giant planets. The first up-close photographs of Uranus and Neptune were obtained by Voyager 2, revealing previously unknown details about their atmospheres and moons. Both Voyager spacecraft are still operating and transmitting data to Earth. Voyager 1 is more than 22 billion kilometers or 13.7 billion miles from Earth as of January 2021, and Voyager 2 is more than 18 billion kilometers or 11 billion miles away. In the event that they are intercepted by extraterrestrial intelligence, they carry a golden record, a phonograph record featuring sounds and images of Earth and its inhabitants. The Voyager spacecraft carries a message for extraterrestrial life in the form of a golden record containing information about Earth's inhabitants, cultures, languages, images, and natural sounds. Also, since the late 1970s, one of the Voyager spacecraft, Voyager 2, has carried a unique instrument known as a cosmic ray subsystem, which has been measuring the strength of cosmic rays in the interstellar medium. The Voyager 1 spacecraft is the farthest distant artificial object from Earth and the first spacecraft to exit the solar system and enter interstellar space. Both spacecraft also feature identical sets of scientific instruments, allowing scientists to compare the outer planets and their moons side by side, giving them better knowledge of the planet's similarities and differences. The Voyager program is regarded as one of history's most successful and long-lasting space missions. It has revealed fresh facts about the solar system's furthest reaches and broadened our understanding of the universe. Scientists are continually studying and analyzing the data and photographs collected by the Voyager probe, and new discoveries are being made. But has one of these discoveries become something to worry about? What are the strange signals we're getting back? Well, while the spacecraft continues to function correctly and transmit back data for scientific research, the mission team is looking into the reason for an issue with the data being collected by the system. To begin with, Voyager 1 is completely operational, which means it's receiving and carrying out directives from Earth and gathering and transmitting scientific data. However, the readings from the probe's Attitude Articulation and Control System, or AACS, do not accurately reflect the actions taking place on board. These AACS control the orientation of the 45-year-old spacecraft. And in addition to its other responsibilities, it keeps the high-gain antenna precisely directed towards Earth, allowing the spacecraft to communicate with us. Although the telemetry data produced by the AACS is corrupt, there is significant evidence that it is still perfectly working. To paint you a clear picture, the data may appear to have been generated randomly, or may not reflect any of the states that the AACS is even theoretically capable of being in. The issue has not triggered any of the onboard fault protection systems. These mechanisms put the spaceship into safe mode, where only critical functions are carried out. This provides the engineers more time to determine the source of the problem. The signal from Voyager 1 has not lessened, showing that the high-gain antenna is still orientated properly concerning Earth. The team will continue to monitor the signal to determine whether the inaccurate data is being created directly by the AACS or by another system contributing to the creation and transmission of telemetry data. However, the crew cannot speculate on the potential impact on the spacecraft's ability to continue gathering and transmitting scientific data until the nature of the problem is better understood. The current distance between Voyager 1 and Earth is 14.5 billion miles, or 23.33 billion kilometers, and light takes 20 hours and 33 minutes to travel that distance. This means it takes approximately 2 days to send a message to Voyager 1 and receive a response, a delay that the mission team has grown accustomed to at this time. Suzanne Dodd, Voyager 1 and 2 project manager at NASA's Jet Propulsion Laboratory in Southern California, said that a puzzle like this is sort of normal for the course at this stage of the Voyager mission. Well, since both the spacecraft are reaching their 45th birthdays, which is much older than the mission planners anticipated. Furthermore, we have entered interstellar space, an area of extraordinarily powerful radiation that no spacecraft has ever traversed. As a result, the engineering team is confronted with several severe issues. However, she is optimistic that the team will find a solution to the AACS problem if one even exists. Dodd also stated that the team is unlikely to find the source of the abnormality and will instead learn to live with it. Suppose scientists are successful in discovering the source of the problem. In that case, they may be able to resolve it by modifying the spacecraft software or utilizing one of the redundant hardware systems. While it wouldn't be the first time the Voyager team had to rely on extra parts. In 2017, the primary thrusters used by Voyager 1 began to show signs of deterioration. And as a result, engineers opted to abandon the thrusters that had been previously employed during the spacecraft's contact with planets. Despite not being used for 37 years, those thrusters still worked flawlessly. Voyager 2, the exact twin of Voyager 1, is currently 12.1 billion miles or 19.5 billion kilometers beyond Earth, and is still operating as expected. Both Voyager spacecraft are the only spacecraft actively gathering data in interstellar space. The Voyagers were designed to operate for a far shorter period than they did, and since their launch they have greatly contributed to the knowledge gained by humanity about the heliosphere, which is a diffuse barrier produced by the Sun that surrounds the planets in our solar system. Every year, each spacecraft generates around 4 watts less electrical power, limiting the amount of technology that may be operative on the spaceship. The mission engineering team has shut off several subsystems and heaters to conserve power for scientific instruments and critical systems. No scientific instruments have been shut off due to the decreased power, though, and the Voyager team is working hard to guarantee that both spacecraft continue to function and return original scientific data well beyond the year 2025. While the engineers work on understanding the puzzle that Voyager 1 has offered them, the mission scientists will continue to make the most of the information that is being transmitted from the spacecraft's unique vantage point. It's possible that the spacecraft may no longer be able to interact with Earth in the future, but they will continue to sail through interstellar space as time passes, carrying information about our civilization for any extraterrestrial intelligence that may come across them. So don't worry, even if we become extinct, we might actually be revived after millions of years by a smarter civilization.